Hello everyone, welcome to Gate Academy Global. So my dear friends, due to some reason, yesterday I was unable to take your YouTube session. Okay, so not to worry, sometime these things happen. As I told you, from now to onwards, your class will never get missed. Okay, so let's start. In the last session, we have covered the movement of packets. So out of 4 addressing mode, I have discussed 2. Okay, MAC address as well as IP address. Now let's see about the port address, how we can implement the port address and what is the need of port address in a transport layer. Okay, so see with the help of IP address, basically a packet get delivered to the final destination. Are you getting my point or not? With the help of IP address, just try to imagine a situation. Okay, just try to imagine a situation. Suppose this is the server, and somewhere this is the client which is communicating with this server, and these are connected through big intermediate network. Okay, so just imagine this is the big intermediate network. Okay, so this is the source point, or you can say source host, and this is the destination host, which is nothing but a server. So you can consider any kind of server. Suppose this is the Gmail server. Okay, now if this particular host wish to communicate with this server, definitely it will require the IP address. So with the help of IP address, what will happen? The packet will get delivered to the final destination. Yes or no? So just imagine a situation. See here in this situation, with the help of, please note it down, with the help of IP address, the packet will get delivered to final destination. Yes or no? So with the help of IP address, what is happening? The packet will get delivered to the final destination. Now if the server wish to reply to this particular source node, so definitely it will also create the packet, and the packet will be transmitted to this particular source node. Now just imagine a situation inside the source node. See, inside the source node means inside the computer, means from the computer we basically access the internet, means from the browser we basically access the internet, and through the browser we can access the multiple server at the same time. Yes or no? Through the browser we can access the multiple server at the same time. Suppose you have opened 4 different tabs. You have opened 4 different tabs. In one tab you are trying to access the Gmail server, in the another tab you are trying to access WhatsApp web, in the another web you are suppose you are trying to access like a Facebook server, like this. Okay, so I'm considering this particular node. Okay, so just see over here. Suppose this is the computer through which we are accessing multiple server at the same time. Okay, and this is the outgoing path, or you can say this is nothing but internet wire. Through which you are connected with the internet. Now in this particular node we are running multiple applications, means we have opened the various tab. Okay, like this. Okay, in the first tab we are accessing the Gmail server, in the second tab we are accessing suppose Facebook server, in the third tab we are accessing IRCTC, and in the fourth tab we are accessing suppose you can take any WhatsApp. Okay, just imagine a situation. So my dear friends, what is happening over here? Through my computer and using the web browser, we are accessing multiple web server at the same time. Now Suppose one web server will be over here, second web server will be over here, and the third web server somewhere else here, and the fourth web server is somewhere else, because all the web server is not residing at the same location. Different web server have a different location. Are you getting my point or not? Like suppose if you are accessing the TikTok, so the web server of the TikTok is basically in China. So you cannot, like, even the Gmail have multiple web server. Even the Gmail have multiple web server, because it is quite difficult to accommodate all the client informations inside the single web server. So we basically distribute the web server to just overcome the load inside the server. Are you getting my point or not? So just see over here. Suppose through this computer and using the web browser, we are accessing multiple web servers. Suppose this is the Gmail web server, okay, and this is the IRCTC web server, okay, and this is the, suppose, Facebook web server, and this is the WhatsApp web server, okay, WhatsApp web server, okay. So if you are accessing the multiple web server at the same time, what will happen? Definitely, if you are requesting something to the Gmail web server, definitely you will get the reply from the Gmail web server. Similarly, the reply can come from the IRCTC, the reply can come from the Facebook, the reply can come from the WhatsApp. And whenever the reply will come, the reply packet basically required source IP as well as destination IP. So whenever the packet will be created, this is the reply packet sent by the Gmail server. This is the reply packet sent by the Gmail server. So definitely in this reply packet, there will be a source IP and there will be a destination IP. And the same thing will happen for the IRCTC, Facebook or WhatsApp. Yes or no? So with the help of this particular destination IP, the packet will reach over this host. Are you getting my point or not? All the reply packet will reach over this host. Are you getting my point or not? All the packet will reach over this host. Means with the help of destination IP, because the IP address basically useful for the host to host communication. This is the one of the host and this is the another host. So with the help of destination IP, what will happen? The packet will travel through the network and it will finally reach to this host. But delivering the packet to a particular host is not our ultimate target. Yes or no? Why? Please try to think about it. Delivering a packet to a destination host is not our ultimate target, because inside the destination host there are various applications running at the same time. So ultimately you can say these are the nothing but application running, or in another words you can say these are nothing but the process. See basically what happened from the web server, the script basically come to the like final destination host. From here what is coming inside the packet? The scripting language is coming, or scripting code is coming, and the scripting code can be executed through the browser. So once the scripting code will reach over here and it will be executed by the browser, then only you will be able to see the information written or contained by the packet. Suppose you are watching the images, you are watching any text file, you are watching anything. So basically from the web server the scripting code is coming, and that particular scripting code will execute inside your web browser, and once it will be executed you will be able to see the information display inside the browser. Yes or no? Display inside the browser. So scripting code in running mode means code in execution, basically called the process. Yes or no? So all these application we can say simply these are the process. Are you getting my point or not? Simply you can say these are the nothing but a process. Is that clear? Everyone, please say honestly. If you are having any doubts, you can text me in my Telegram group, okay, or you can text me personally, not a problem at all. Wherever you are like finding any kind of doubts, you can just share with me, not a problem at all. So just see over here. So with the help of destination IP, all these packets are reached to the final destination. But how? Now in this point, how the computer will decide which packet is come from for which application, which packet is targeting which application. Are you getting my point or not? Because the reply is coming from the WhatsApp server, Facebook server, IRCTC server and Gmail server. Because reply can come from any server, and there is only one path from which the packet can enter inside the computer. Now how the computer will decide which packet has to be forwarded to which application? Are you getting my point or not? So what we are observing over here, with the help of IP address, the packet will get delivered to the final destination. Now the second point is how once packets will reach. Okay, how computer will decide that which packets belongs to which application. Are you getting my point or not? Which packet belongs to which application? So definitely in this point also we required a addressing mechanism. The addressing mechanism, because without having a particular ID means like addressing mechanism means ID. You are assigning the unique ID. So without the help of ID, we cannot find out that which packet belongs to which application. Are you getting my point or not? Because that IP address basically implemented in a network layer, and the port address basically implemented in a transport layer. So definitely if you will assign a particular ID to each application process, then definitely we are able to find out which packet has to be forwarded to the which application. So basically what happened, whenever we create a process inside the browser, whenever we will try to access any web server, so definitely this process will be created. So whenever the process will be created, it has to be assigned a unique ID. Suppose we have assigned the unique ID 2222 to this process, 3333 to this process, and 4444 to this process, and 5555 to this process. And this ID is basically assigned at the transport layer. So once you are opening a application process, and if you are assigning it a unique ID, so definitely whenever the reply packet will come from the Gmail server, in a destination port, it will put what? 2222. Are you getting my point or not? So whenever the reply packet will come from the final source point, so definitely inside the destination port, which is implemented at a transport layer, it is going to put this one. Because first time, suppose there is a server, always client request for a particular pages to the server never request to the client initially. What happened, means like just opening a web browser, do we find any kind of reply directly coming from the server? No. Until and unless the client will try to access the server, the reply can never come. So always the request is generated from the client side, and this is nothing but a client. So whenever the request will be created from the client side, what will happen? Just see over here. So suppose if this is the client, okay. So suppose this is the client, okay. So here in a client side, there is a transport layer, there is a network layer, there is a data link layer, and so on. So whenever the packet will be created at the transport layer, what will happen? In the transport layer, whatever coming from the upper side, that is the session layer, it will attach two things. One is the source port and the second one is the destination port. So here there will be a source port and there will be a destination port. So suppose if this client is trying to access the Gmail services, okay, or Gmail web server. So definitely it will put the client source port as its on port, that is the 2222, and inside the destination port it will put suppose 80. So whenever the packet will be created in a transport layer, it requires two addresses, source port as well as destination port. So at the transport layer we basically implement port address whose size is how much? 16 bits. So out of means from the 16 bit you can create 2 to the power 16 unique ID, yes or no? 16 unique ID. So out of 2 to the power 16 unique ID, there are ID 0 to 1023 which are called well-known port number, reserved for special purpose. Are you getting my point or not? So any port number apart from this will be usable by the client. So any port number apart from 1024 onwards to 2 to the power 16 minus 1, these are used by client. Yes or no? So these are the well-known port number and these are reserved for the special purpose. So what are those special purpose? I will discuss later on. Not to worry right now. Once we will move to the transport layer, I will discuss it. Why we are reserving this port number for the special purpose, I will definitely discuss once we will go to the transport layer. Then you will be able to feel it. Okay. So any port number apart from this will be used by the client. Got it, everyone? So definitely in the client side at the transport layer whenever the packet will be created, and definitely in the transport layer the packet will be created only when you will open a tab and you will try to access any server. So suppose you have opened a tab. Once you will open the tab and you will type www.gmail.com, immediately a unique port number will be assigned to that process. And suppose that unique port number is nothing but 2222. So definitely in the transport layer, source port number will be assigned as this and the destination port is this. And definitely once this packet will come to the lower layer, that is the network layer, what the network layer will do? Whatever coming from the upper side, the network layer will simply implement what? Source IP as well as destination IP. So in place of source IP, the client will put its own IP address, and in place of destination IP, it will put the IP address of the Gmail server. Are you getting my point or not? And in this way, the things basically happen. So definitely the destination IP will be used to deliver the packet to the final destination. Are you getting my point? The same thing we are implementing over here. So once you will open up application process, immediately a unique port number will be assigned to that process. So definitely if you are assigning this particular port number as a source port and the request is going to the web server, so whenever the web server will create a reply packet at the transport layer, suppose the application server is replying to this query, so definitely at the transport layer it will put the source port, it will put the destination port. So inside the destination port it is going to port 2222, yes or no? In place of destination port it will put 2222, whatever coming inside the source port of the requesting packet, that will become the destination port in a reply packet, yes or no? Suppose I am sending you a parcel, so definitely whatever the source address given inside the parcel, it will become the destination address whenever you will reply to me, yes or no? The same thing is happening over here. So whenever the server will reply this particular query in a destination port, it will apply this one. So similarly, if IRCT is replying the query definitely it is going to use the destination port as a 4444, because from the source side, whenever we have started running the IRCTC web server, immediately the client has assigned a unique port number 4444 to this process. Are you getting my point or not? So suppose at the same time multiple reply packets are reaching to this host. So with the help of IP address, the packet has reached to this final destination. Now, how the client will identify which packet has to be forwarded to which application? So definitely here we are going to use what? The port address to identify application process uniquely. Are you getting my point or not? Everyone. So suppose this is the reply packet coming over here having a port address this, and this is having a port address 4444, and this is having a destination port this, and this is having a destination port again suppose 5555, and this is again having a destination port 2222, and this is having a destination port 3333. So definitely these are nothing but the destination port address available inside the packet. So looking upon the destination port address, this one will be forwarded to this application, 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 and this one will be forwarded to this application. Are you getting my point or not? Everyone. Is that clear? So looking upon the port address, that is the destination port address, the computer or your browser will decide which packet has to be forwarded to which application. So here basically we use the concept of port address, and the last address was the specific address, and already I have told you what is the purpose of implementing the specific address. See, writing www.gmail.com in the URL bar, the request cannot be sent to the Gmail server. The request cannot be sent to the Gmail server. You require the IP address, and initially the client don't know the IP address. So you need a mapping mechanism to convert the domain name in a IP address. So once the IP address will be gained, only then the request can send to the server, and for this purpose we basically use DNS protocol, domain name system protocol. So basically domain name system protocol is used to identify the IP address with the help of domain name, that is the www.gmail.com, www.facebook.com. Are you getting my point or not? So with the help of domain name, we are just trying to identify the IP address. For the human being, it is quite difficult to remember the IP address, and that's why we try to remember the only domain name. And in that purpose, we basically use the specific address. So this was all about the introduction of the computer network. So I hope yesterday I have in the last session I have given you a task. Please read the starting 2 chapter of the book Frozen. Okay, computer network book Frozen, and I hope all of you have studied the starting 2 chapter and gain a lot of things about the introductory part of the computer network. There are many other things which are given, like network topology, means how the node can be connected inside the network, mesh topology, bus topology, and ring topology, like this. Apart from that, there is a mode of communication. What kind of mode of communication can be established between two communicating nodes? Simplex, half duplex, full duplex. So these are given inside the first 2 chapter. So once you will start reading it, you are not going to find any problem. As I told you, you are not going to fetch any kind of problem. Once you will start reading it, you will be able to gain a lot of things. And since this is the introductory part, in the entire computer network, we will discuss all the introductory part in details. And that's why I have told you, whatever the concept required inside the introductory part, I have delivered to you. And it's your responsibility to read the starting 2 chapter. Okay. Once again, I am telling you, if you haven't studied till now, go and read it. Okay. Now I am directly starting from the next chapter, that is the data link layer. Okay. So let's move to the data link layer. Okay, and give the heading introduction of data link layer. Okay. So just see over here. introduction of data link layer. Okay, introduction of data link layer. See, in the movement of packet, already we have seen the data link layer is basically responsible for link to link communication. Link to link communication means if there are two nodes which are directly connected through this link, okay, through this link. So in this link, the protocol that we are going to use inside the data link layer will be implemented in this particular link. So this is nothing but a link, or sometimes you can say medium, or sometimes you can say this is the channel. And what we know about the data link layer, okay, it is responsible for link to link communication, okay. Link to link communication means between this link, between this link or between these two nodes, if the packet is moving, what are the situations that are going to be happen? What are the situations that are, or what are the things which are going to be happen, and how to control all those things? For that reason, we basically required a set of protocols. Means if the packet is moving through this link, then the protocols involved over here is come to the data link layer. Means all the protocol which we are going to study inside the data link layer will be held inside this link. Are you getting my point or not? If you are like learning about the framing protocol or media access protocol or flow control protocol or error control protocol, all the protocols which comes under the data link layer will be applicable inside this link. Got it, everyone? All the protocol that we will learn inside the data link layer will be implemented inside this link. Okay, now let's start. What are the, first of all, please try to understand what are the protocol that we have to actually study inside the data link layer. Okay, so I'm just writing a syllabus of the data link layer. Okay, protocol used in data link layer. Okay, protocol used in data link layer. Okay, the first protocol that we are going to discuss is the framing and bit stuffing Second protocol that we are going to discuss is the flow control protocol. Okay, so inside the flow control protocol we have to learn stop and wait, and second one is the sliding window protocol. Okay, sliding window protocol. Inside the sliding window protocol we have two different protocol. One is called go back N protocol and the second one is called selective repeat protocol. Okay, GBN means go back N, you can write over here. SR means selective repeat protocol. Okay, so these are the protocol we have to study inside the flow control protocol. Okay, and the third topic which we have to cover inside the data link layer is error control protocol. Okay, means we will try to understand what is the exact meaning of all these protocols. Okay, so just don't worry. First of all, let me write the syllabus of the data link layer. Okay, so error control, inside the error control protocol we have to study two things. One is the error detection error detection, and the second one is the error correction. Inside the error detection, again we have to study many things. The first one is simple parity check. The second topic that we have to deal with is the 2D parity check. And the third topic is the CRC, and the last one is the checksum. So these are the topics that we have to study inside the error detection technique. Okay, so in error correction technique we have to study only one thing, that is the Hamming code. Okay, Hamming codes. So these are in our syllabus inside the error control protocol. And the last topic is media access control. Media access control protocols. Okay, so inside the media access control protocol basically divided into two parts. One is the contention free, and the second one is the contention service. Okay, the media access protocol has been divided into two parts. One is called contention service. Okay, service, and the second one is the contention free. Inside the contention service we have to study Aloha, pure Aloha. The second topic is slotted Aloha. The third topic is exponential backup algorithm. Okay, algorithm. I'm writing all the topics and the subtopics according to the GATE syllabus. Please try to understand. I'm writing each and everything according to the GATE syllabus, and then I will mark according to the GATE frequently asked weightage. Okay, which are the topics from where the GATE frequently asks the questions. I will mark each and everything so that you will have a proper mind setup how to study each and everything. Okay, so let's see over here. Exponential backup algorithm, then persistent CSMA. Full form of the CSMA is career sense multiple access. Okay, so inside the CSMA we will learn about the persistent method. So first of all we will learn about what is CSMA, and then inside the CSMA we will learn about the persistent method. Basically there are various persistent technique, so we will learn each and every persistent technique through which we will implement the CSMA by CD protocol. Okay, so the next one is the CSMA by CD and CSMA by CA. Here basically CD stand for collision detection and CA stand for collision avoidance. So basically this protocol is used in wired medium. Okay, and this protocol basically all these that we have written over here, these are the nothing but protocols. Whatever the things we are writing over here inside the syllabus, these are nothing but protocols, because inside the computer network all the time we talk about the protocols. Okay, so just see over here, CSMA by CD CA protocol, this is applicable in wireless network, or you can say wireless medium, simply you can say. Okay, now in contention free protocol there is only one protocol that we have to study, that is called polling protocol. Okay, earlier the token ring was in our syllabus. There was two protocol earlier that we have to study, token ring and polling protocol, but token ring has removed from our syllabus in 2019, and that's why we will only learn about the polling protocol. If anything will change inside the syllabus, definitely later on I will teach you, so just don't worry. If any changes will happen inside the syllabus, I'm just writing all the things according to GATE 2022 syllabus. If anything will happen later on, I will teach you definitely, so just don't worry. Okay, don't worry. Okay, so these are the things basically we have to study inside the data link layer. Now let's come to the marks weightage. See, usually every year from the data link layer 3 to 5 marks question has been asked. Once you will look upon the GATE previous year questions, usually every year 3 to 5 marks question has been covered from this particular chapter. This is the chapter which I am writing. Okay, this is the chapter which I am writing, or you can say this is the chapter 2. In the first chapter you can keep introduction of computer network that we have covered till now. This is the second chapter that we are going to discuss, and this is the one of the biggest chapter inside the computer network, from where maximum questions has been asked. That's why I have written the marks weightage of 3 to 5. See, from the computer network, usually the GATE asks 8 to 10 marks, out of which there are two biggest chapter. One is the data link layer and the second one is the network layer. So inside the data link layer, basically we have to deal with the four topics, or you can say what you can say, you can simply say the topic, not a problem at all. So inside the data link layer there are basically 4 topics that we have to deal with: framing and bit stuffing, flow control protocol, media access protocol, and error control protocol. So let's come to the priority of the concept. See, usually every year one question has been asked from the flow control protocol, so you can mark it triple star. Once you will look upon the last 10-year questions, every year one question has been asked from the flow control protocol, and that's why I have given it triple star. It means frequently the question has been asked in the GATE paper. Okay, so once you will look upon the first topic, that is the framing and bit stuffing. So my dear friends, in the last 32 years, only 3 times the question has been asked from the first topic, that is the framing and bit stuffing. So this is not frequent, means out of 10 years only one question has been asked. So you can just mark it as a single star. Okay, this will means marking of these things will give you the idea how to study the computer network, or how to cover each and every topic inside the syllabus. Because basically we study a lot of things, but once we appear for the exam, there are very limited things from where the GATE usually asks the question. Yes or no? GATE can never cover each and every topic inside your question paper. Are you getting my point or not? Otherwise your question paper will have like 200 question in place of 65 question. Usually in a GATE paper we have a total 65 number of question, out of which 10 questions belong to the aptitude part. So technically we have only 55 number of questions. So once you will try to, once the GATE will try to cover up each and every topic, then it has to put total 200 to 250 questions. Are you getting my point or not? And that is not possible. So specifically the GATE focus on a selected topics every year, and they make a little bit changes between 2 and 3 topics. So there are certain topics from where the GATE always asks the question, out of which this is the first topic, flow control protocol, from where you will usually get one question every year, and that question can be of 1 marks or it can be of 2 marks. That is not a concern. The concern is GATE usually asking one question from this particular topic. Okay, so once you will talk about the framing and bit stuffing, in the last 42 years the GATE has asked only 3 times question from this topic, framing and bit stuffing. So out of 10 years you can consider only one time the question has been asked. So that's why we have marked it as a single star. Now let's come to the error control protocol. So from this topic, once you will look upon the previous 10 years, last 10-year question paper, almost 6 to 7 times the question has been asked. Okay, so you can write over here 6 to 7 times in last 10 years. So what you are feeling over here? Almost the weightage is 60 to 70%. 60 to 70% means every after 1 year the question will be asked from this particular topic. Okay, so you can just mark it double star, and you can just mark it double star or like double star and half star. You can say yes or no, double star and half star. Similarly, once you will talk about the media access control, then almost 6 to 7 times in last 10 years. Also here you can evaluate that you can mark it double star. So more or less both the topics, either it is the error control protocol or it is a media access control protocol. So either the question will be, if the question will be asked from the error control, they will skip this one. If the question will be asked from the media access control, they will skip this one. Or they can ask the question from both the topic. Like 1 marks from here, 2 marks from here, or 2 marks from here, 1 marks from here. Are you getting my point or not? So usually what happens, sometime if the gate is asking the question from the error control protocol, they will skip this one. And if they are asking the question from this particular topic, they will skip this one. Or another possibility is they will ask the question from both the topic. One will be of 1 marks and the second will be of 2 marks, or both will be of 1 marks. Are you getting my point or not? So more or less you can think that all the topics that we are going to cover inside the data link layer have a equal weightage. All the topics are very important, because only after learning the data link layer protocols you can secure 3 to 5 marks in your gate scorecard. So you can't ignore anything inside this chapter. Are you getting my point or not? Everyone, just say something. So we can't skip anything inside this chapter. So ultimately these are the 4 topics that we are going to cover inside the data link layer protocol. So whatever the protocol we have written over here, like framing protocol, flow control protocol, error control protocols, and media access control protocol, all the protocols will get implemented inside this link. Means a link which is connecting 2 different nodes, out of which one could be a source node and the second one could be a destination node. Or you can say if this is the sender, then this is the receiver. One node, you can say this is the sender, a node which is sending a data packet, or you can say data frame, because in a data link layer we assign the packet name as a frame. Sender means a node which is sending a data frame. Receiver means a node which is receiving a data frame. Are you getting my point or not? So let's try to understand the meaning of each and every protocol. So first protocol that we have written over here is framing. Okay, please try to understand the meaning of each and every protocol. Then from the next session, I will start from the first topic. Okay, since this is the introductory part, so please try to understand the meaning of each and everything, because at the beginning of my class I have told you, always try to connect the name with the concept, then you will never forget anything in your life. So see, the first topic that we are going to cover inside the data link layer protocol is the framing protocol. So framing name come from the frame. See, inside the data link layer we assign the packet name as a frame. So what is the meaning of framing? The meaning of the framing is creation of frame. So you can simply say creation of frame. So why the creation of frames are needed? Why the creation of frames are needed? Please try to understand. Suppose this is the source and this is the sender and this one is the receiver. So just think about a scenario. This is the sender and this one is the receiver. At the sender side there will be a data link layer and there will be a physical layer. Similarly at the receiving end there will be a data link layer and there will be a physical layer. So the frames are always created at the data link layer. Suppose these are the frames created at data link layer, so on. So once this frame will come to the physical layer, the physical layer never understand the packet. It always understand the stream of bits coming from the upper layer. So whenever these frames will goes down to the physical layer, what the physical layer will do? Whatever the stream of bits coming from the upper layer, it will simply convert it into the signal, and finally the signal will propagate through this medium. And once the signal will reach to the receiving point, what the receiver will do? It will convert the signal into a stream of bits. It will convert the signal into a stream of bits. Are you getting my point or not? So at the receiving end, the physical layer will convert the signal into the stream of bits. So my dear friends, once the physical layer will capture the stream of bits from the signal, what the physical layer will do? It will simply forward this stream of bits to the upper layer. Now, what is the responsibility of the data link layer? What is the first responsibility of the data link layer? Creation of frames from this sequence of bits. So here what the data link layer will do? It will create, or you can say form frames from stream of bits coming from physical layer. Are you getting my point out? So once the physical layer will transfer this sequence of bits to the data link layer, the first responsibility of the data link layer is to create the frame out of this stream of bits, and this process is called framing protocol. So how these things are happening? What are the logic involved inside this protocol? That is the matter of discussion inside the framing protocol. And when the concept of the bit stuffing is required, because I have written the topic name framing and bit stuffing. So what are the logic involved while creating a frame at the receiving end? That is the matter of discussion inside the framing protocol. Okay. And what is the need of bit stuffing concept? That again we will discuss. So this is the first thing that we are going to discuss inside the data link layer. The another thing is we have written the second topic that we have written flow control protocol. So I hope you are understanding the flow control protocol. What is the meaning of flow control protocol? See, if the sender and receiver are communicating with each other, then what is the time required by the packet to deliver from one point to the another point? What is the time the sender will take to transmit a given frame into the, or to drop the given frame into the medium? Those are the part of flow control protocol, because you are analyzing the timing which is required to deliver a particular packet or frame to the receiver. Those things are involved inside the flow control protocol. Because what will happen? Suppose I am a sender, or this is the sender, and the sender have this particular frame. So definitely this frame will have some size. So how much time this sender will take to deliver or to drop this particular frame from its buffer? Because inside the sender there is a buffer where the frame is residing. Are you getting my point or not? So how much time the sender will take to drop this frame from its buffer to the wired medium, So once the frame will come to the wired medium, it will become the signal, and signal always travel with the velocity of light. So once the frame will be dropped inside the medium, how much time this frame will take to deliver into the receiving point? So analyzing the time is the part of flow control protocol. what is the total time the sender will take to deliver a particular frame to the destination, or you can say to the receiver. Those are the part involved inside the flow control protocol. So ultimately we are going to study about the all type of delay involved in a flow control protocol and how the things are happening or how the protocols are involved. What is the actual meaning of stop and wait protocol means in a minimum time how can we deliver maximum number of packet. Those are the part of flow control protocol. See, if I am sending only one frame, once the acknowledgement will receive, I will send the next frame. If I will implement this kind of logic, so definitely just think about your internet speed. The internet speed will be very slow. But if you are sending the frames back to back, then here the question is arising, how many frames the sender can send back to back? There should be a limitation, because suppose if I am sending a 20 number of frames back to back and you have only 10 number of buffers available, then what the receiver will do? It will accept only 10 frames and the remaining 10 frames will be discarded because the receiver do not have a sufficient buffer. So how can we maintain the flow of packet? Those are the part of flow control protocol that I will discuss in details. Okay. So the next topic that we are going to cover over here is error control protocol. Error control protocol. And I hope at the beginning of the session I have discussed about this. Suppose this is the sender and somewhere this is the receiver. Okay. And sender is sending a data frame 1011 and the medium is unreliable medium. So what can happen? Any bit can modify. So if this packet will be transmitted to the receiver, definitely this kind of change can happen. So suppose if this particular bit has been modified at the receiving end. Once the receiver receive this particular data, suppose this is the data sent by the sender, and once it reached to the receiver, this particular bit has been modified. Then here the question is how the receiver will identify which bits has been modified. Are you getting my point or not? Which bits has been modified, how the receiver will identify this? Of course, we need a certain set of protocols to identify this, and those are the part that we will discuss in a error control protocol. Okay. So the last topic is the media access control protocol. What is the meaning of media access control? So already I have given you the best example. If multiple nodes, okay, fourth media access control, if the multiple nodes are trying to access the common medium, there is a chances of collision. Suppose if node A and B are sending their data frame at the same time to the common medium. This is nothing but a common medium. If more than one node are sending their data frame at the common medium, there is a chances of collision. So if collision will happen, definitely the data inside the frame will get modified, means will get changed. Then our ultimate responsibility is to minimize the rate of collision. So to avoid or to minimize this particular collision, there are various protocols involved, and all those protocols that we will discuss inside the media access control that I have written. One protocol is the contention free, second protocol is the contention service. See, contention basically means collision. So whenever I am writing contention service, it simply means the collision will happen. We cannot remove it. But if the collision is happening and we cannot remove it, then our ultimate target is to reduce the rate of collision. Are you getting my point or not? And another protocol is contention free, means collision free. Means we are designing a protocol in which the probability of the collision will become 0%. So protocol is nothing but a logic. What kind of logic we are going to implement so that we can reduce the rate of collision or we can remove the collision. Are you getting my point or not? And those are the matter of discussion that we will discuss inside the media access control. So protocol is nothing but a logic. Already I have told you. So once you are implementing a protocol anywhere, there will be a involvement of extra bits, and the extra bits that you are going to introduce inside the packet will be calculated with some logic. And those things we are going to see from the next lecture. So my dear friends, in the next lecture, I will start the first topic, that is called the framing and bit stuffing. So I hope all of you people are enjoying the subject a lot, and if you are really enjoying it, hit the like button and put your valuable comments, because your one comment will inspire a lot of students, okay, and the crowd will come to this platform, and once the crowd will come, you, me and everyone will enjoy the session. So keep learning, stay motivated, and take care. Bye everyone. Bye. Good night.